So here, you'll be doing the cis or trans isomers in a cyclic structure. Right. Now the term cis and trans, as you have learned just now, this could be applied for certain carbon-carbon double bond molecules. But in this topic here, we focus on the use of cis and trans in a cyclic structure. Here you see a cyclopentane, 5 carbon in the ring. Now let me give you some substituents here. A bromine and a chlorine. Notice how I draw the bonds here. Both are wedges, that means both are pointing towards you. And if both substituents are pointing towards you, we call it cis. Next example, we have a cyclohexane. A fluorine group, hash bond, pointing away from you. And at the other position, let me just put a CH3, a methyl group. Now for that molecule, we can call this a trans. Then you think, why can we call this a trans? Remember, cis and trans, you have to refer to the same substituents. Right? Cis means on the same side. And trans means on the opposite side. But in this case, there are even same substituents as fluorine and methyl. So why are we able to call it cis and trans? Don't forget, every carbon has 4 bonds. So here, the one that's not shown must point at you, a wedge bond. And at the bottom here, the last bond must be a hydrogen that's of a hash line. So these two are identical and they're on the opposite side. That's why it is trans. Same for this just now. The last 2 bonds are not shown for the hydrogen. And they're the same. And they point to the same side. That's why it's cis. Next example. In here, you see 2 methyl groups adjacent to each other, connected to these 2 carbons, and an ethyl group pointing to the back of the plane. Now for this molecule, you have to use these words carefully. You cannot say that the whole molecule is cis or the whole molecule is trans. It doesn't make sense. Because here, there are 3 substituents pointing in, either in front of you or the back of the plane. So you have to be clear and tell us which 2 groups you are referring to. But I can still use cis and trans for this molecule. The 2 methyl groups are cis. So now I'm focusing on 2 of them. These 2 methyl groups are pointing to the same side at you, and they're cis. Or I can say that the methyl and ethyl groups are trans. Because both methyl groups are pointing to the same side, but the ethyl group is pointing to the opposite side. So this means opposite and they're trans. And like I mentioned just now, although these 2 are different, it is because of the last bond that's not being shown to you, the hydrogen, that makes the difference. I hope now you're clearer on how to use cis and trans in a cyclic structure. Please practice more to be better.